All right, guys. The second part of 2425 is piecewise functions. We talked, I don't know, one of these sections about evaluating a piecewise. Like if I said to you, evaluate this piecewise, that's not what this question's asking, but I'm just showing you what I'm talking about. Hang on. All right, like if you had f of, say, -2, and then we're going to evaluate f of 3. We are looking here. This is our boundary. This is our parameter. They're telling you if the value that you're trying to evaluate with is less than or equal to 1, use the top example or the top expression. If the value that you're using is greater than 1, then use the bottom one. Do you guys understand that? So if you're going to evaluate, this would be 2x plus 3, and this one over here you would use -x plus 4, correct? So this would be 2 times -2 plus 3. So -4 plus 3 is -1. And then over here, this would be -3 plus 4, which would give us +1, yeah? Okay. So we're not evaluating the piecewise functions now. We're actually going to graph them. And this is super duper easy. It's a lot easier for you to do on Notability than it is for me to do on here. You'll see why in a second. But when you are graphing piecewise functions, all you're doing is graphing lines or parabolas or something. But you can graph the whole thing, but you don't want the entire line. You just want a piece of it. So what you're going to do is you're going to look at like number 1. Do you guys agree with those are both lines? 2x plus 3 and -x plus 4, right? F of x is a fancy way of saying y. So you are going to graph the top line, and you're going to graph the bottom line. But on the top line, what are the only values I want? Where x is what? Less than or equal to 1. The bottom one, I only want the values where x is greater than 1. So that's all we're going to do. We're going to take these two lines. We're going to graph two lines. We're going to figure out what we're looking at. There's a couple different ways you can do this. Some of you are going to want to try and do it all in your head. I don't think that's the best idea, but you know. All right, so I'm going to rewrite this. I'm going to do one in blue. All right, so in blue, I'm going to write y equals 2x plus 3. Because remember, f of x is a fancy way of saying y. So I recognize here that my slope is what? 2, so 2 over 1. And my y-intercept is 3. So I'm going to go to my graph here. It's a positive line. If you need to go like this, remind yourself it's positive so you don't make a silly mistake. That's cool. But to graph this, I'm going to put my intercept at 3. And from 3, I'm going to go up 2 and over 1. Up 2 over 1. Down 2 over 1. Down 2 over 1. You guys agree? Well, that kind of got weird. Down 2 and over 1. Now, I'm going to connect my dots with a dotted line. And you'll see why in a second. I think you should do the same thing too. So I'm just going to go like this. Now, a piecewise function doesn't want the whole thing. It just wants a piece of it. So this is where that parameter, we'll say, comes in, this boundary. I only want the stuff on this line where x is greater than or less than or equal to what? 1. So I'm going to draw a line right here at 1. On the x-axis, guys, where are all the values on the x-axis less than or equal to 1? To the left of the red line I drew or to the right? To the left. What kind of a dot do I have in my inequality? Look at my sign. It's less than or equal to. So right here at this boundary line, I'm going to close up that dot. Excuse me. I'm going to close up that dot, and I want all of this stuff over here to stay. And then what do I do with the rest? I'm going to erase it. I don't want the stuff on that side. So your piecewise function, all you're doing is you're going to graph the line or the parabola, whatever it is, but you don't want the whole thing. You just want a piece of it. And that boundary line, that inequality behind it tells you what piece you want to keep, what piece you don't want to keep. Yep. Yes, closed dot means it includes the value. Open dot means it doesn't. Good question. All right, so now I'm just going to use a different color. Excuse me, I'll use red. My second line, I have y equals -x plus 4. What's my slope here? -1 over 1. My y-intercept is at 4. Remember, my line is going to go downwards. So I'm going to go up here to 4, and I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. You guys with me? Up 1 over 1, up 1 over 1. So where on this line do I want to keep, and where do I want to erase? Well, what does your boundary line say? Where am I looking at? Sometimes it's the same, sometimes it's not. Again, we're looking at where x is what? 1. So look at this. Now I drew a yellow line. Where, in regards to my yellow line, are all the values on the x-axis greater than 1? To the right of it or to the left of it? To the what? Right. To the right. So what kind of a dot am I going to have here? Why is it open? Because it doesn't have an or equal to. Make sure I can see that you want it to be an open dot. And then I'm going to keep all this stuff over here and do what with the other piece? And I'm going to erase it. You see why it's easier on Notability? So your piecewise function looks something like this. It's a piece of this and a piece of that. Questions? Anybody have any questions?
The line is on 1, right? Like that yellow line?
Yes.
So we just put it whatever the value is next to it.
Yep. Okay. Sometimes it's the same. Do you know how both of these have the same, the boundary lines at once? Some of them there's not. There's a break in it, whatever. All right, let's go to the next one. Again, what kind of shape am I creating with both of these equations? They're both lines. They're both to the first power. So again, I'm going to write y equals -1/2 x minus 6. And then over here I have y equals x plus 5. In both cases, what's my boundary line? Where am I looking at? -4, okay? Sometimes, like I said, it's the same. Sometimes it's not. So my slope here is -1/2. And my y-intercept is at -6. So it's a downward sloping line. So -6 down here. Up and over which way? To the left, good. Up and over which way? To the left. Up and over which way? To the left. Everybody with me? Okay, so something like this. Now, I'm going to draw my boundary line. It says less than or equal to -4. So 2 things I need to look at. Which side of this line do I want to keep? Which side do I want to erase? Do I want to keep the left-hand side or the right-hand side? I want the values that are less than or equal to -4. I want to keep the stuff on the left. What kind of a dot do I want to have right there at that boundary line? And I'm going to have a closed dot. Why is it closed? Because it says or equal to, it's included. And then what do I do with all the other stuff? I erase it. I just want a piece. Not the whole thing, just a piece. That's the only piece of that line that I'm looking at. Does that make sense? All right, let's go to the next one. Y equals x plus 5. Slope is 1/1. Your y-intercept's at 5. So go up here to 5. Up 1/1, up 1/1, down 1/1, down 1/1, down 1/1, down 1/1, down 1/1, right? Again, where's my boundary line in this case? At x equals -4. So at -4, guys, what kind of a dot should I have there? I should have an open dot. Why is it open? Because it's not included. So you keep everything over there. Make sure. Do you see how I made sure that you guys saw that dot was open? Yes. Now, on your homework, I know there's some where like the 2 things connect. Sometimes they do connect, sometimes they don't. If one is supposed to have a closed dot, one is supposed to have an open dot. Can you show an open dot and a closed dot at the exact same spot? No. So what would happen, you think? What supersedes, a closed dot or an open dot? Closed. Yep. Good. But do you understand why it's called a piecewise? It's just pieces. That's it. All right, 2 more, and then we're done. How is 3 a little different from the first 2 we did? There's a parabola, okay? In your mind, right now, tell me, what shape is this parabola? It's a U. Is it an upwards U or a downwards U? Upwards, because it's positive. And then where did it move from the origin? Down 2. Good. All right, so let's go ahead. And I'm going to say y equals, I'm going to rewrite this as x plus 2. Am I allowed to do that? Yeah. Yes. I just like it to be in y equals mx plus b. So my slope here is 1/1. I don't know why I wrote 2. So 1/1, and my y-intercept is at 2. So let's, I can't believe I'm losing my voice. Up 1/1, up 1. It's a positive line, so do you guys agree? Something like that? And then where's the boundary that I'm looking at? At x equals 2. So let's look where x is 2. I want all the stuff where x is less than or equal to 2. In regards to my vertical green line, where is all the stuff less than or equal to -2 on the x-axis? On the left side. So we're going to keep all of this, And do what with everything else? Bye-bye. And what kind of a dot do you want to have here? It's closed because it's, or equal to, it's included. Good job. Bye-bye. Now the next one, can I just identify where it crosses the x-axis and know what this, no. When you guys have a parabola, because you want your points to be correct, you don't want to just have an approximation, but in your mind you should know about what it looks like. We should throw in some values. I'm going to throw in a couple values to the left of the boundary line so I can get a good picture, and then a couple points to the right. So I'm going to use, we'll say 0, 1, 2, and 3. So when I plug in 0, what's 0 squared? 0 minus 2, negative 2. What's 1 squared? Minus 2. 2 squared is minus 2. 3 squared. 9. 3 squared. 9 minus 2 is 7, all right? I need to find points so I can plot my parabola. So I have 0, negative 2. I have 1, negative 1. I have 2, 2. I have 3, 7. And then the next one would be somewhere up there, right? So my boundary line, guys, is again at 2. So where are all the x values now greater than 2? My boundary line is that green one. Where are all the values greater than 2? To the right. So is this a straight line? No. What kind of a dot should I have here? It should be open. So make sure it looks like it's open. And then it should be a parabola-ish looking thing like that. Do the best you can. Is it going to be perfect? No. But should it be a straight line? No. So a parabola-ish looking thing. It's not always the case where the boundary line is the same every time. It's not like that all the time. There could be a break in the in the graph. It could be right on top of each other. It's fine. All right, let's look at the last one. How many things am I graphing here? 3. Tell me about them. One's a line and the other 2 are parabolas. Perfect. All right, so I'm going to pick 3 colors. Whoops, pick 3 colors. Y equals 2 over 3x plus 1. And then I have y equals x squared minus 1. And then I'm going to have y equals negative x squared plus 3. Am I allowed to rewrite it like that? Yes. Do you have to? No. I'm just going to do that because I like the way that it looks. So, blue. What's my slope? 2 over 3. And where is it crossing the y-axis? At 1. It's a positive line. So at 1, I'm going to go right here. And then go up 2 over 3. Up 2 over 3. Down 2. Down, and over. 1, 2, 3. Okay. So, where is the boundary line that I'm looking left and right for this one? Negative 1. So I'm going to go ahead and draw a line right here, negative 1. I want all the values on this blue line that are less than or equal to negative 1. In regards to my pink, where is that? On the left-hand side or the right-hand side? On the left. Do I have a closed dot or open? It's closed because it says we're equal to. So I'm keeping that part of my graph, and then I'm crossing everything else out, erasing it. Okay, let's go to red. Red is what shape? Parabola. It's going what direction? Is it positive or negative? It's a positive parabola, so it's facing upwards, all right? So let's plug in some numbers. Now, you guys are like, where are you getting these numbers from? Well, what are the boundaries? Where am I looking at in between? Where x is negative 1 and positive 1, right? So expand yourself a little bit to just make sure you get the proper picture of the graph. I'm going to use negative 2 to positive 2. Negative 2, negative 1, 0, 1, and 2. So when I plug in negative 2, what's negative 2 squared? 4, and 4 minus 1 is 3. Plug in negative 1. Negative 1 squared is 1. 1 minus 1 is Okay, 0 squared minus 1. Okay, 1 squared minus 1 is, 2 squared is, 4 minus 1 is. Notice the points. 3, 0, negative 1, 0, 3, right? It should mirror each other. It's a parabola. There's nothing wrong with that. Don't think, I did something wrong. So let's go ahead and plot these points. So negative 2, 3. Negative 2, 1, 2, 3. Negative 2, 1, 2, 3. Right there. Negative 1, 0. Negative 1 should be there. 0, negative 1. 1, 0, and 2, 3. Do you guys kind of see your parabola shape? You guys see it? Okay. So where's the boundary line? Now I have 2 that I'm looking in between. What are the 2 that I'm looking at? Between where? Negative 1 and positive 1. So I only want the stuff that's between negative 1 and positive 1. I only want the stuff from here to here. And what kind of dots do I have on the left-hand side? Open. And what do I have on the right? Very good. So that's an open dot. I'm going to make sure you guys see that it's open. And this one over here is closed. It's the only part of the parabola I want. That's it. Now my next one, I'm going to do in yellow, and then we're done. If you did not rewrite it, that's fine. You could leave it as 3 minus x squared. It doesn't matter. But where am I looking at? I want the values that are what than 1? Greater than 1. So I'm going to pick one value. That's to the left. I'll do 0, then 1, 2, and 3. You can plug in whatever you want, but I would do whatever's right around the boundary line so you can see what you want to keep and what you want to throw away. If I have a negative, guys, look, well, it doesn't really matter here, but 0 squared, 0. So negative 0 plus 3 is just 3, right? When I plug in 1, guys, this says negative 1 squared plus 3, like that. It's not negative 1 squared. It's you're plugging in the 1 for x and square it, then you stick the negative with it. So 1 squared is 1, then negative 1 plus 3 is 2. Okay, so now I'm going to plug in the 2. I square the 2 first. 2 squared is 4, then times the negative 1. Negative 4 plus 3 is negative 1. Good. Now I have here. Square the 3. 9. Negative 9 plus 3 is negative 6. Now, think about this from what we talked about yesterday. What kind of a parabola do I have here? Is it a happy one or a sad one? It's sad. It should be going downwards. So your point should indicate that. If not, you should go back and say, wait a second, I might have made a computational error here. Because it's the negative is out in front. It's over the x-axis.
Oh, because you put the 3, you put x plus, you put negative x plus 3.
Yeah, I mean, you should be able to recognize it just by looking here, but that's why I like to rewrite it, just so you can see it. So 1, 2, 1. Ay, ay, ay. It's been a long day. Erase this. Okay, we're back to it. Okay, so 0, 3, 1, 2, 2, negative 1, and then 3, negative 6. You guys agree? It's my parabola. Again, in your mind, it's a parabola, so it's not a straight line. But where's the boundary line we're looking at here? Where x is what? Greater than 1. So here's 1 again. What do I want to keep and what do I want to get rid of? Where do I want to keep the stuff? On the right or the left? On the right. I want to keep all this stuff over here. I want to keep this stuff over here, and I want to get rid of anything to the left. But what kind of a dot do I need there, guys? I need an open dot. Look at this. I want you guys to see something, and then I'll stop talking. These are all functions, correct? What do we know about functions and x values? They can only have one. So do you see how we have on top of each other? You have the yellow piece of the parabola, and you have a red piece of a parabola. You will never have two closed dots right on top of each other. You might have where like your lines for one equation stops here, and then the next one starts here, to where one was open, one is closed. That's okay, but you will never have two included dots on the same x value. It will not.
Will you never have two open dots?
Yeah, you can have two open, but you can't have two closed. But do you see how all we did was graph one line and two parabolas on one graph? You just have to figure out what values you want to keep and what values you want to get rid of. When I say keep and get rid of, you use your parameters here. This tells you, okay, this is where I want all the x values bigger than this. I want them less than this, that sort of a thing. Sound good? All right, we're done.